Some quick wrap-up comments here on two sample methods. First, we mentioned that back in the one sample case that the t-test was robust, right? At least in the one sample case, and that actually extends to the two sample case. And in fact, the two sample case is actually even more robust than one sample. And then if we see distributions that are very strongly not symmetric, we can actually still use two sample methods, right? All it said in the assumptions, if we were to revisit those, were that um, the populations that we draw from must have similar shapes. So we could, they could be very not normal and still do a t-test and it actually works. Okay, so just be aware of that. And then the ideal case is that we have sample sizes that are equal, okay, and population distribution similar. If that happens, then the p-value that we report is actually pretty darn good and pretty it provides good evidence for us. Well, enough statistical evidence, I'll say. Whether we reject or fail to reject is another question. But ideally, we want to try and make sample sizes the same from our populations whenever possible. Okay, and then your book mentions the pooled two sample t procedures. This is the case in Excel if you're using the data analysis toolpack that would use equal variances. Okay, equal variances is the when you get a pooled test. And I'm not going to go too much into this, but this assumption works out very rarely in practice. So I would say avoid equal variances whenever possible. And I do provide a link from Penn State on this, so you can take a look at it there. But generally in practice, if you do what we do, or if you use the methods that we introduced in these videos, the equal variances case is contained in the uh, unequal variances case. So really, there's no reason to do equal variances if you can do the unequal variances case. So let's simplify our lives and only remember one. So that's all I have to mention on this. We'll get some practice with the two sample t-tests.